Hello student, once again I'm Sudhi and welcome back to my video. And today in my video I will explain more about the chapter number 5, that is exercise 5.8 and 5.9, the remaining part of the chapter number 5. So today here we have the topic quadrilaterals. So quadrilaterals already I have started explaining in my previous video. Now today I will just add one more quadrilateral to explain. So the last one which I have to be explained is your trapezium. So trapezium, you see what is a trapezium? Trapezium is also a quadrilateral where four sides are there, and some kind of property is with this four side quadrilateral, so that it's called the trapezium. Why it is called trapezium, or what is the property with the trapezium? Let us see that see, this is the figure of the trapezium. See, we know that we have the set square in our geometry box. So the same set square uh, where you can find three sets square together, then you see how we arrange and we can get a kind of a figure that is having four sides. And in that four side you can see that two sides here above and below, they are parallel to each other. Okay, they are parallel to each other and other are not parallel. So this is the four side where only a pair is happens to be parallel, but the other are non-parallel. So such kind of figure is called trapezium. And how we can explain into definition is here: trapezium is a quadrilateral in which a pair of two opposites is two side a pair of two opposite sides is parallel. A pair, only one pair means only two sides will find that it is parallel, but the other two sides will be non-parallel. This is called trapezium. Once again, trapezium is a quadrilateral in which a pair of two opposite sides is parallel. Now, let us see what is polygon. The next topic is polygon. So what are the polygon? Let us see. So polygon, when we talk about the polygon, it is a closed figure only, not open figure. It is a closed figure only, and it is bounded by four sides or four line segments. This is called those are called polygons. So let us see what the polygons are. Polygons are a simple closed plane figure. They're bounded by the line segments. And here we have some more polygons here, and these polygons are of different type. And this different type of polygons are according to their number of line segments they are having as their sides. You see here in the first column is the number of sides, and second column is name of the polygon, and the simple or sample are here given. Okay, so name number of sides. For example, a polygon having three sides. Polygons with three sides are called triangle. And next, the polygon which is having four sides are called quadrilateral. And the polygon having five sides are called pentagon. And polygon having six sides are called hexagon. And polygon with eight sides are called octagon. So these are some few that given in the book, and we can know more if we like to know. So the here polygon with seven sides are not given here. Is called yes, polygon with the seven side is called heptagon, and polygon with the nine side is called nonagon, and the polygon with the 10 side is called decagon. Yeah, decagon. So like this, we have a number of polygons, or means different type of polygons according to the uh, different number of their sides. Okay, so this is called triangle, quadrilateral, pentagons, hexagon, and octagons are there. So they are the polygons having different number of sides. So 7 is called heptagon, and 9 is called uh, nonagon, and 10 is called decagon. Okay, when there is 10 sides, it's called decagon. Okay, so these are the some example of polygons with different number of sides. Now let us go to the next part of the chapter. So here we have the next part of the chapter, same chapter only. Then we have exercise. So next we have exercise 7.5. So in 7.5 we have the question number 1. Here in the question number 1 we got here say true or false. So we have to say true or false here. So the question number 1 is angle of a rectangle is right angle. It is true or false. Once again we have rectangle. We have a quadrilateral called rectangle. In this rectangle all the angles are right angle, means having 90 degree. Yes or no? Let us see the answer. We have the solution here, and the solution is yes, it is right. Okay. And question number 2 we have the question like this: the opposite sides of a rectangle are equal in the length. Means the opposite sides. Okay, the opposite sides of the rectangle are equal in length or not. Let us see the solution. Yes, it's again it is true that opposite sides are equal in rectangle. Okay. And question number 3: the diagonal of a square is perpendicular to one another. Once again, diagonal means the line that is joining the two opposite vertex is called diagonal. If we draw the diagonal, two diagonals of the square, so they used to be perpendicular to one another. It is right or wrong? Let us see. Yes, the answer is yes again. Now next we have a question number 4, and question number 4 is saying like this: all the sides of a rhombus are of equal length. Yes, rhombus and the square are having some kind of same property, that is all the sides are equal, isn't it? Yes, this also yes. The answer is yes. Now next we have question number 5, and the question number 5: all the sides of the parallelogram are equal in length. No, it is not going to be yes, it is no. Okay, then all sides of the parallelogram are not uh, equal as in the rectangle. Only opposite sides are equal. Okay, so in the parallelogram also opposite sides are equal as well as they are parallel. Okay, but not all the sides are equal to one another, so that statement is wrong here. And we have question number 6, and the question number 6: the opposite sides of the trapezium are parallel. The opposite sides of the trapezium are parallel. The opposite sides of the trapezium means not, it is the sentence means that all the sides means there are two pairs, four sides are there, that means two pairs of sides are there, means two pair of opposite sides are there, means all are not equal parallel. Only one pair, only two are parallel, not all. So the sentence means that all are parallel. That's wrong. It's no. Here again the answer is. And now let us go to the next question. We have the next question, question number 2. So we have the question number 2. The question number 2 is give reasons for the following. Okay, yeah. See, a square can be thought of as special rectangle. Once again, square is a square can be thought of as special rectangle. Means square also could be somewhat a special rectangle or not, because you see rectangle have some properties. These property are all there in the square or not. You see, I will just try to memorize you that rectangle, in rectangle opposite sides are equal, isn't it? Opposite sides are equal and all the angles are 90 degree. These properties, if we found in the square, then we can say that square is also a special rectangle. So let us see here in the solution what is the explanation here about this statement. It is saying that all the properties of the rectangle are there in the square, so we can say that a square can be thought as a special rectangle. Okay. The next statement is a rectangle can be thought as a special parallelogram. Why a rectangle can be thought as a special parallelogram? Special parallelogram. So the result, or in the solution, we have like this. Yes, all the properties of the parallelograms are there in the rectangle. What is the properties of the parallelogram? The properties of the parallelograms are that the opposite sides are equal, isn't it? The opposite sides are equal, and the diagonals are bisect each other. So these two properties are also there with the rectangle. Therefore, we can say that rectangle is also a special parallelogram. Now, next statement is a square can be thought of as special rhombus. So why we can say that square is also a special rhombus? Now let us see what is the explanation here. All the properties of the rhombus are there in the square. So what are the properties of the rhombus? Is that the rhombus sides are all equal like the square, and also the diagonals are perpendicular to one another. That's why it is said that rhombus, I mean a square also a special rhombus. Okay, next we have D. In D, the statement is given like this: squares, rectangles, parallelograms are all quadrilaterals. Yes, square, rectangles, parallelograms are all quadrilateral. Why? Because they are having four sides, isn't it? All the four sides figure are called quadrilaterals. So let us see the statement here. There's the explanation, or the answer is all the four sides closed plane figure are known as quadrilaterals, because square, rectangle, parallelograms are all the figure having four sides. That's why they are called quadrilateral. Okay, next we have E. In the E we have square is also a parallelogram. Square also a parallelogram. So how we can say that square is a parallelogram? Because all the properties of the parallelogram are there in the square. So what is the property of the parallelogram that is uh, same with the square? Is that, so my dear student, in the parallelogram we have the property that opposite sides are equal, and the diagonals are bisect each other, isn't it? In the same way, in the properties of the square, the opposite sides are equal. Opposite sides are equal, and the diagonal also bisect each other. Okay, so this is the same property. That's why square also a parallelogram. Okay, next we have question number 3. In question number 3, we have the question like this: a figure is said to be regular if its sides are equal in length and angles are equal in measures. Suppose let us say a figure is there. If the figure is having all the sides are equal and the angles are also equal in measures, and what you can say about the figure? Suppose any figure, maybe three-sided, maybe four-sided, maybe five-sided, maybe six-sided, doesn't matter. Okay, so if all the sides are equal as well as all the angles are equal, then it is called a regular figure. A regular figure. Okay, regular figure. Then can you identify the regular quadrilateral? So the question is asking us that can you identify a regular quadrilateral? Means the regular quadrilateral means having four sides. Okay, and all the angles are same as well as all the sides are same. So what could be the regular quadrilateral here? The regular quadrilateral means nothing than your square. So we have the answer here. Let us see the square or not. Yes, the solution is given like this: a regular quadrilateral is a square only. Okay, so this is the answer of the question number 3. And now let us go to the next question, question number 4. uh, Sorry, we don't have the question number 4 here. We have uh, finished the exercise 5.7. Now we are going to the exercise 5.8 and 5.8 question number 1 we have. Okay, in question number 1 of the exercise 5.8, it is saying like this: examine whether the following are polygons, and if any one among them is not, say why. We have to get the reason why they are not. If it is a polygon, yes, we have to say yes only. See, the exercise 5.8 is about the polygons only. Polygons, we know about what is a polygon. Polygon is of the closed. Polygon is a plane figure that used to be made of line segments, isn't it? And different type of polygons are there. For example, triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. These are all the type of polygons with different number of the sides, isn't it? So these different type of polygons are used to be classified according to the number of the sides they are having, isn't it? That much only we have to know. And then more about the polygons, more about the different type of polygons we will study in the higher classes, but only this part let us know. Okay, so the question number 1 here is: examine whether the following are polygons or not, and if one is not happens to be polygon, and we have to say that why it is not a polygon. So here we have diagram. A diagram here is given like this: A, B, C, D. It is diagram from your book only. So four diagrams are there. Out of these four diagrams, we have to find out which are the polygons and which are not the polygons. Okay, clear. So let us see in the solution. In the solution, we have A. It is not. It is not a polygon. Yes, you can see the line segments are there, and lines, even though it is like having line segments, it is not a polygon. Why? Because it is not a closed figure. You can see that it start from one point and it just end another, but they are not closed. They are not joined together, isn't it? So it is not a polygon. And B, it is or not. It is yes. B, of course, it is a polygon. You know all, isn't it? So B answer will be yes. And there is nothing to be told because it is a closed figure and made by the line segments, isn't it? Yes, there are polygon. And next, C definitely not. Why? Because it's not done by using line segments. There is no any line segments we can see in making this figure, so it is not a polygon. And number D also not polygon because it is not closed by the line segments. Yes, you can find two line segments are there, but what happened? It is not closed by the other line segment. It is by the curve only. So this is not a polygon. Okay, so these are the results and answer for question number one of the exercise 5.8, and we have the next question. So let us see the next question. So next question of the question, next question and the exercise 5.8, we have question number two. In question number two, it's asking us to name its polygon and also make two examples of its. Now we are going to name the polygon and we will find the figure here, we find the example here, diagram here, and according to the number of the sides we are going to name the polygon, isn't it? Naming the polygon is the matter the sides, isn't it? How many sides are there, how many uh, line segments are there in the side that we have to take it and we have to name the polygon. So let us see the diagram given here. So these are the diagram. There are four diagrams A, B, C, D. They are all polygons. It means these are the figure made by the line segments, isn't it? And also they are closed figures. So these are all polygons. So we are going to give the name of each of them and also have to draw an example of other two the same kind. Okay, so what is that number A called? Let us see what this type of polygon is. In solution, A is called quadrilateral. Why? There are four sides, isn't it? All the four sides polygons are called quadrilateral, and and we have uh, examples of its kind, that is square and rectangle, isn't it? Yes. And next we have triangle. Three-sided polygons are called triangles. Three-sided polygons are called triangle, and two examples of such type is the same way only. That's, you can see that in different way when you draw them it become a two example. It's okay. So anyway, like this we are giving. And see how many sides are there. There are five sides. So what can you tell about the polygon having five sides? It is called pentagon. So C it is pentagon, and different type of the same kind. You can draw like this, one up, one down, doesn't matter, it's okay. Then D, how many sides are there? One, two, three, four, five, six, seven, 8 sides are there. If the polygon is having 8 sides, it is called octagon. Yes, D is octagon, and different type of octagon. Here you can see one is regular, yeah, regular octagon only. So same way only, just we draw the same, because uh, how much we can make different, they must have the same 8 uh, this sides only, isn't it? We cannot make square here, or we cannot make any other triangle here. Okay, we have to make the octagon only with the same number of sides. So this is the answer for question number two. Now we have the next question. Let us go to next question now. Next question is question number five, and I'm just leaving this question number three and four. The three and four is your homework, and three and four you can try yourself. Okay, clear by understanding some idea of the polygon. No need to worry. If you have difficulties, then you can ask me. It doesn't matter. But you just keep on trying. Trying is the best for you. Now, question number five. The question number five we have the question like this: a diagonal is a line segment that joins any two vertices of polygon and is not a side of the polygon. Draw a rough sketch of the polygon and draw its diagonal. Once again, let us try to understand the question here. A diagonal is a line segment that joins any two vertices of the polygon and it's not the side of the polygon. We know what is the diagonal. Diagonals are not the side of the polygon, but diagonals are the line segment that joins two opposite vertices. Not any two, but if we say any two means it could be a side, okay, but it that any two vertices should be a opposite vertices, two opposite vertices, two any opposite vertices. If it's joined by a line segment, that line segment is called a diagonal. Okay, clear? Then here it is asking us to draw a rough sketch of a pentagon and draw its diagonal. You know what is a pentagon? Pentagon is the polygon which is having five sides, and we are going to draw the diagonals of these five sides that polygon called pentagon. Now let us see. Here is the diagram of the pentagon. You can count the sides. The sides are here five. The sides are all five here. Then it is A B C D E. The pentagon A B C D E, and you can see that how to draw the diagonals. You can see A and D are joining, D and B also joining, and A and C also joining, B and E also joining, and E and C also joining there. And these joining lines of such vertices means the opposite vertices are called diagonals. So here you can see the diagonals. Okay, clear? Not ED. ED is a side, DC is the side, AB is a side, BC is a side, AE is also side, but AC is not side. It is called diagonal and is the line segment that joining two opposite vertices. And then we have here like this in the solution. We can explain our solution. Let ABCD be the rough sketch of the pentagon. To draw its diagonal, what we have to do is that we have to join AC, AD, BD, DE. You can see DE. Yeah, sorry, D. Yeah, DE. DE is not supposed to be here. So here just once again, so to join the to draw the diagonals, we have to join AC. It's okay. Now AD, that's okay. BD is okay, and DA, not DE. It should be DE. Okay, it's not DE is not a diagonal. Okay, clear? DE is not a diagonal. So here we have a little things to do. Here student, you just once again come back here, join AC, AD, BD, and this is not DE, it is actually BE. Okay, BE. Once again, joining AD here. Okay, AD here, joining AD, BD, and BE. Okay, BD and BE, not DE and CE. We have to join. Okay, once again, we have five diagonals are here, and out of five diagonals here, DE is not the DE, it is the BE. Okay, please correct it down. Here you can see BE here, so it is BE. So this is the typing mistake, so please note down once again, this DE is not the DE, it is BE. Okay, BE. Here you can find here BE, so this BE is not DE. Okay, it should be BE. Now then the line segment AC, AD, BD, DE, and CE are its diagonal. So here we have five diagonals of this pentagon. And let us go to the next question. And next question, we don't have next question. We have only option question number 5 of this exercise. And dear student, question number 3 and 4 are your homework. Please do it, all of you. Okay. So and try to show me in my personal WhatsApp after doing this. And if you have really problems, you can consult with me. We can discuss together, okay, in our other time. So let us go to the next part of our lesson. Next we have another topic of the lesson, that is the last topic, that is three-dimensional shape. Three-dimensional shape. What is three-dimensional shape? See the figure, we said 3D, 3D, 3D. So what is 3D shape and what is 2D shape? So far we are discussing about polygon, isn't it? Like square, rectangles, then we say pentagon, hexagon, octagon. These all shapes are called 2D shapes, where you can find only length and breadth are there. But if a figure is having length, breadth as well as height, then it is called three-dimensional shapes. But you will study about the uh, breadth as yeah, we'll study about the shapes having length, breadth and height. So this length, breadth, height will not come, but you have to keep in mind that three-dimensional shapes are having length, its breadth and its height also. Okay, clear? So let us see what is the three-dimensional shape. And the three-dimensional shape, three-dimensional shapes are the shapes having length, breadth and the heights. Then we have some figure here of the three-dimensional shape. You can see football, ice cream cone, that your and drum, isn't it? Or it is called cylinder, and box you can see. Then you can see that die or kind of shape called pyramids. So you see the ball is a shape of sphere. Sphere is a kind of 3D shape. When the circle is having its length, breadth, and height, then it is sphere. And you can see cone. Okay, yeah, cone when the when when the triangle have a surface, okay, have a base surface, that is called cone, you can see. And then cylinder, you can see cylinder. This is a circle only, but when the circle is having some other property, then it becomes a cylinder. Okay, then box, you can see box is a square or maybe a rectangle. So when it used to have the height, then it is called cuboid, isn't it? Then you can see that Ludo die, that it is a square shape. So all are square here and there, and you can see that it's the square is having length and breadth, and here you can find the height also. So the 3D shape of the square is called cube. And now the pyramid is also a triangle only. So when the triangle, you can see it have some more property, that height or maybe kind of surface, then it is called pyramid. Okay, so once again you see these are all the figure of some 3D shapes here. So ball is as a sphere, then ice cream as the ice cream cone is as the yeah, cone itself only, and cylinder, cubeboard, cube, and pyramids. Okay, so these are some examples of the 3D shapes. Now let us study more about the 3D shape again. So my dear student, we have again some more 3D steps to be studied. Now let us see, yeah, the faces, edges, and the vertices of the 3D steps. So let us see where is the face, where is the edge, and where is the vertex of the 3D steps. Okay, let us see. Here we have one figure here. This figure is called cube. Okay, so here we are going to take one example. Let us take this cube as example. Then let us see what is the face, or what is the edge, and what is the vertices, or we can say vertex. Okay, when if it's single it is called vertex, and the plural it is called vertices. So let us see what is face here. For example, in the cube, here you see that diagram. In this diagram, you can see that where is the face, isn't it? Each side of the cube is flat and called a flat face, or simply a face. The flat surfaces, the flat part of the cube is called face only. Okay, clear. Then next we have two faces. Two faces are made at the line segment. You can see one face above where the arrow is pointing there, and another face is here, another face is here, another face also that side, another face also will be there side, and on the floor side also will be one more faces here. But all these faces are joined with a line segment here. You can see line segments are there, isn't it, joining two faces. So the line segment that joining two faces are called edges. Edges in Hindi you say kinar, isn't it? This is the edge only. So this edge you can see here, that line are called edges. All these lines are called edges. You can see how many edges are there, you can count yourself. So this is called the edge of the 3D shapes. And next we have three edges. Okay, three edges are made at a point. You can see one, two, yeah, three. Okay, first here let's see here, one, two, three, one, two, three, one, two, three are meeting here at a point, and this point is called vertex. Once again, three edges are meeting at a point, and that point is called vertex. So we can see the diagram here. Here is the diagram. You can see one, two, and another line coming from here, three. So these three are joining at a point, and this point where three edges are joining is called vertex. Means just the corner is called the vertex only. Okay, so there are corners of the 3D shapes. So these corners are called vertex. Just in that way you can also. And now let us go to the next part of the lesson. We have some more example of the 3D shapes. So let us see here. Yeah, some more example of the 3D shape. You can see one 3D shape. The 3D shape is called cuboid. So what is a cuboid? So we will explain here. A cuboid looks like a rectangular box only. If a rectangle is having its height, then uh, it is called cuboid. For example, see the face here. You see the face. Only the face is there, then it is a rectangle. So what happened? The face used to increase its height, isn't it? Height from ground to certain height, certain level. Then when it gain the height, then it is called cuboid. What is that? The rectangle, isn't it? This a rectangular box only. So next we have a square type of things, and when the square is having its height, okay, then it is called cube. So this is a cube, and a cube is a cuboid whose edges are all equal. So it is somewhat like the cuboid only, but all the edges are equal, all the edges. See, these are edges, isn't it? The edge is the line segment you can see here, and they are all equal to one another, and it is called cuboid. But here the line segment are not equal, isn't it? So one will be the length, one will be the breadth, or we say width, okay, and the other will be the height. Here the length, the breadth, the height will all be same in cube. That's why it is called cube. Now next we have another figure, that is pyramid. Here it is a triangular pyramid, and here in triangular pyramid you can find that a triangular pyramid has a triangle shape uh, as its base. It is known as the tetrahedron also. Tetrahedron means made of three faces of the uh, triangle, okay, tetrahedron. So you can find that this triangular pyramid, pyramid have a triangular base. Okay, that's why it's called triangular pyramid. This is pyramid only. Now next we have another pyramid is called square pyramid. In the square pyramid you can find that the square pyramid has the square as its base. Now here in the triangular pyramid the base is triangle, isn't it? And here the square pyramid, the base is square. Now next we have another that is called triangular prism. So in triangular prism you can find that a triangular prism looks like the shape of a kaleidoscope. Kaleidoscope. This triangular prism also can be found in your science labs. They're used for your physics also. If you go to physics lab, then you can find this triangular prism. They are made of glasses only. Okay, clear. And it is also a type of kaleidoscope only. Kaleidoscope is kind of a device that you have studied in science also. You study in the science. Okay, don't worry about the kaleidoscope. Now it also has the triangle. It has triangle as its base also. You can see here this is this triangle as the base here. Okay, next we have another figure. There is your cylinder, and you have cone here, and you have sphere here. But this three D shapes, this figure which is called 3D shapes of cylinder, 3D shapes of uh, cone, and the sphere, they don't have edges. Okay, so a cylinder, yeah, a cylinder, cone, and sphere have no straight edges. Once again, here the cylinder, this is a cone, this is a sphere. So the cylinder, the cone, the sphere, you can see here, they have no straight edges like the other we have. Okay, so these are some example of the 3D shape. Now we will go to some more example of 3D shape. So my dear student, So some more examples of 3D shape you can find here. So let us see some part of this. So this is the cube. This is the cube we have, and the cube, see different edges, different spaces of the cube you can have. Okay, you can see once more. Yeah, see, yeah, you see, can spinning here, isn't it? Spinning very nicely. You can see once again, see different edge, different faces you can see here. And next we have a cuboid. You see cuboid, how the cuboid look like. You see this is a 3D set that I'm just arranged for you to understand the proper faces, edges of the 3D set. This is a cuboid. Okay, cuboid here. You can see. Yeah. So next, let us see next one. So next we have the prism. So this is the type of the prism only. So how the prisms look like. Okay. So all this you can find in your science laboratory. The prism is made of glass only, thick glass. Okay. So this is a prism. So next we have another 3D shape here. There is uh, rectangular prism. Okay. This is a rectangular prism only. Yes. This is called a rectangular prism, how it look like. So from all the angles we trying to see the figure, the 3D shapes. Okay, so this is how rectangular prism look like. Okay, yes. Now let us go to the next part of our lesson. Next part of the lesson, next part of the lesson is exercise 5.9, the last exercise. So let us see what are the questions here in the exercise 5.9. In the exercise 5.9 we have question number 1. In question number 1 we have match the following. So let us see what to match what to match is here. Okay, now we have the question as diagram here. In this diagram you see a cone, B sphere, C cylinder, D cuboid, and E pyramid. So we have to match with the figure given on the right side. So let us work it out now. In the solution we have the same figure, and now I'm showing you the method following here. A cone, where it is to match, you see, yes, it is Roman number 2. And sphere, where is the matching, we are matching at 4, yes. Then cylinder, that cylinder is at 5. And cuboid where it is in Roman number 3, and the pyramid where it is, yeah, it is in the Roman number 1. And the small solution here about this question here we have, yes, these are the solutions. Okay, then we are going to just name some more of the same kind, cone or sphere or cylinder, some more examples. So some more example, let us see about this all figure. We have here some new examples. There is cone, conical, tent, and sphere, tennis ball, or we have a ball of wool. A cylinder, we have measuring jars, and a cylinder. Okay, cylinder, gas cylinder we have, isn't it? Yeah. And the cuboids, brick or matchbox, these are some examples of the cuboid. Pyramid, the pyramid of the Egypt, that you know in the movie, isn't it? Yeah, if you go to Egypt you can see the example of pyramids. Big and huge pyramids are there. Those are made in almost olden days of the pharaohs, means the kings and queens of the Egypt in the olden days. Okay, so these are the answer for the, I mean, solution for the question number 1. Now let us go to question number 2 here. The next question. Yes, my dear student, we have next question, question number 2. In question number 2, we are going to say what the set is now. Let us see. Number A, your instrument box. Then number B, a brick. Then number C, a matchbox. Number D, a rod roller. Number E, a sweet laddu. So what are these sets called according to our 3D sets? Okay, so let us see the answer here. The answer is number A, we have our instrument box is a cuboid shape, and number B, a brick is a cuboid, and B also cuboid means a brick also a cuboid, and matchbox also cuboid, and rod roller is cylinder, and sweet laddu is, now we have sphere. So these are the answer of the question number 2, and here we have the answer or the solution of the 5.9 here. And let us go to the next part of the lesson. Now student, next we have the lesson at a glance. What we have studied in this lesson, let us try to look once again. Here we have no solution, let it be. Then in the first point we have this is not the question. Okay, this is not the question. This is just like at the glance of the lesson only, just to look back again to the lesson what we have studied, okay, in chapter number 5. The distance between the endpoints of the line segment is called its length. Then number 2, the graduate ruler and the divider are useful to compare the length of line segments. So it means we are using the ruler and divider to use the uh, to use for comparing the lengths of the line segments, means to measure the line segment. Okay, then uh, when a hand of the clock move from one position to another position, we have an example of at angles, means every movement of the hand clocks used to form an angle. That's what we have to do. Okay, and one full turn of the hand is called revolution. If the hand complete its turn, one turn, okay, one complete turn, then it is called one revolution. Then we have a right angle is 1 by 4 of the revolution, and a straight angle is half of the revolution. When we use protractor to measure the size of the angle in degrees, then we have measures of a right angle is 90-degree, and hence that of a straight angle is 180-degree. Once again, do not forget that right angle means having 90-degree and straight angle means 180-degree. And next we have an angle is acute. An angle is acute if its measure is smaller than that of right angles. Once again, an angle is acute if its measure is smaller than that of right angle. Means if the angle is having less than 90-degree, then that angle is called acute angle. Next we have and is obtuse, an obtuse angle. Okay, an obtuse angle if its measure is greater than that of right angle, means more than 90-degree, then it is called it is called obtuse angle, and but it is less than straight angle. Once again, uh, the angle having measurements, or the angle having its measures more than 90-degree but less than 80-degree, it is called obtuse angle. Again, a reflex angle. A reflex angle is larger than the straight angle. If the angle happens to be more than 180-degree, then that angle is called reflex angle. Next point we have 4, that is two intersecting lines are perpendicular if the angle between them is 90-degree. For example, when you draw two line segments are joining at a point, and at the point of their joining there will be some angles. Okay, if the angles happen to be right angles, then the two lines are called to be perpendicular to one another. Next we have the 5th point, that is the perpendicular bisector. The perpendicular bisector of a line segment is a perpendicular to the line segment that divides it into two equal parts. When you talk about the perpendicular bisector, if it is only perpendicular, they may be joining at different points of the lines. Okay, but if it is perpendicular bisector, the perpendicular lines will be joined at a certain point, at the point where it divides the line segments into equal parts. Then the lines is called perpendicular bisector. If the perpendicular bisector, if the perpendicular line is joining at a point where that point is divided a line segment into equal parts, then it is called perpendicular bisector. Bisector, bi means two, sector means divided. Okay, clear? Two parts, equal parts, that is called bisector. Next we have 6. Triangle can be classified as follows based on their angles. So we have many triangles there, like scalene triangle, isn't it? And equilateral triangle. Then we have uh, right angle triangle, or obtuse angle triangle, acute angle triangle. These all are different type of triangle, and triangle are used to be classified based on their angles also. If it is classified as according to the angle, then right angle triangle, obtuse angle triangle, or acute angle triangle we have. Okay, then we have again triangle can also be classified as follows based on the length of their side also, how much the length of the sides. Okay, for example, all the length of the side are equal, then it's called quadrilateral equilateral triangle. And if the lengths are not equal at all, okay, or all different, then it's called scalene. And if only two sides are found to be equal, then it's called isosceles triangle. Like this we have classified the triangles. Yes. So next we have 8, that is polygons are named based on their sides. Yes, different type of polygons we have come across, that is triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. These are all type of polygons and having different sides. Then next we have number 9, point number 9, that is quadrilaterals are further classified with the reference to their properties. So quadrilaterals is a polygon having four sides, and many quadrilaterals are there with different properties. So according to properties, we name them as square, rectangle, parallelogram, rhombus, kite, or trapezium, like this, isn't it? Yes. Next, last point we have 10, that is we see around us many three-dimensional shape, like there are cubes, cuboids, spheres, cylinders, cones, prisms, and pyramids. So these are some examples of the three-dimensional shape that we can find in our surrounding here. So my dear student, this is all about the lesson number 5. And with this, at the glance of the chapter, so I will come to the point of today's I will come to the end point or end part of today's session. Here we come to the end part of the session, and here I will take leave from you. So here we finish our today's lesson, and we'll meet again in the next video in the same channel at the same time with the same with the other different lessons. Okay, so thank you once again for watching my video. So till then, have a nice day, all of you. Bye bye. Once again, thank you for watching my video.